So good afternoon. I think thank you, Energy Exemplar, for giving us the opportunity to speak here. So of course, in first couple of slides, I'll talk about what we do in India and what is basically of course, India is having one of the largest, the integrated power system that we have. So I'll talk about a little bit about what is the current supply positions there. And then, of course, I request my colleague, Dr. Ajit, to share the insights from our initial results that we have worked out on PLEXOS. So, of course, to give you a brief background of TERI, of course, we recently completed, kind of 50 plus years of existence in India. So we do a lot of work on sustainable development. And of course, there are a couple of research areas that we work on: climate change, sustainable habitat, sustainable water, agriculture, and of course, the energy is one of the largest work that we are doing within the organizations. So having said that, of course, I represent our energy program. So my name is Alekhya, as introduced by Daksh, and I have my colleague, Dr. Ajit. So in the energy program, we largely work on industry decarbonization. So I think that is the work industrial energy efficiency group that they used to do with solar, with hard-to-abate sectors like steel, cement, iron, and those industries. And there is a dedicated group working on the energy modeling. Of course, there we do a lot of energy modeling, including the electricity sector modeling for the country, short term, medium term, and the longer term. And of course, I represent the electricity and fuels as a director, and my colleague Dr. Ajit is from the same team. So basically, basically to give you kind of a work that we do, cross-sectoral, and also in India as well as in different countries in the APEC regions and some of the European regions. So we have, the legacy of, earlier we used to call as a Tata Energy Research Institute. It was funded by Tatas. And then in 2000, we have been independent and is kind of the Energy and Resource Institute. So these are the larger footprints of different type of work that we do, including the energy sector and the electricity sector per se. So I represent also, because this is one of the initiative that TERI has undertaken with support from Government of India, Ministry of Power. So we set up an Institute of Energy Transitions. So under that ambit, basically we are doing a lot of modeling work for the country that also includes today's presentation about 2070 decarbonization of the electricity sector. So just to give you a little bit background of the Indian power sector, as I said, I think we are one of the largest, the power system that we have. And of course, all the regional grids are now interconnected. And to share some of the numbers that we have, of course, at present we have more than 520 plus gigawatt of installed capacity. Of course, one of the recent achievements that we have, we crossed more than 52% of non-fossil fuel capacity. Our target was by 2030, but we achieved in last year, December 2025, we achieved our target of more than 50% non-fossil fuel capacity. Having said that, I think the solar is dominating. We crossed around 140 odd gigawatt of solar capacity in the country. And by 2030, we are going to achieve 500 gigawatt of renewable targets. And of course, during the course, we also achieved a lot of private sector participations. Of course, you people are already seeing a lot of, the tariff that are discovering through reverse bidding or auctions. The competitiveness that we have achieved, particularly in the RE space in solar, to be very precise, that is, I think, one of the landmark, particularly in this sector. So, of course, a lot of capacity addition has done, particularly after 2014 when this new government are in place. Solar capacity, if you see clearly, almost 40x type of capacity addition that we have done. Wind also, of course, there are larger room to increase the wind power capacity as well in the country. And subsequently, of course, the storage, both short term, medium term, and the longer term, that is also in developing now. On the other hand, I think we have at present close to 30% of the generation mix that comes from non-fossil fuel. Of course, that includes wind, solar, and of course the hydro. And if I can give you any numbers, like last year, I think in the month of June, July, and August, like 3 months, I think we achieved even more than 40% of non-fossil fuel in the generation mix that we have. So having said that, of course, there are a lot of studies for the Central Electricity Authority recently coming out with a national level resource adequacy plan for 2034, 2035. And of course, NITI Aayog has also recently published a 2070 net zero roadmap that includes the electricity sector. But of course, when we do our the demand assessment for the electricity sector, considering the different type of loads that are coming up in the country, be it from electric vehicles, electric cooking, lot of distributed renewable energy that is also coming into, then of course the electrolyzers and data centers. So we estimated kind of a electricity demand, I think that my colleague will discuss in subsequent slides. And then, of course, before coming into the 2070, the TERI has done first of kind 2030 electricity sector modeling, considering the 19th EPS that Central Electricity Authority have. So we have seen like what type of the dispatch strategies, particularly in this, actually in the low carbon scenarios, what will happen. So this 2030 results gives us another, push to have a midterm kind of a developing a roadmap by 2050. So 2050, we do a lot of capacity expansion plan and considering the high renewables. So we, by 2050, the kind of capacity that we have added under the net zero scenarios, around 1800 odd solar capacity, and of course the storage and all. So there we have seen a lot of land constraint and issues when we grow the solar power. And earlier, the assessment has been done by ministry. They talked about 740 odd gigawatt of the solar potential. So then we feel, I think, when we do the 2070 studies, we have to reassess the country's solar power potential as well as the wind power potential. So we came out with the reassessment of the solar and wind when we are doing the 2070 studies. I think we'll discuss subsequently. So I think now I am, transferring this floor to my colleague, Dr. Ajit, to talk about 2070 modeling that we have done. And of course, then subsequently we'll take up questions. Over to you, Ajit.
Thank you, sir. So thank you, Alekhya, sir, for explaining our past studies which were related to the planning optimal capacity mix for 2030 and 2050. Next, this is our latest study, which we want to study the optimal capacity mix for 2070. 2070 is also the net zero target for India. Now, first we have a look at what motivated us to do a study for 2070. So there are a couple of reasons. Number one, if you see the cost of the technology that is changing drastically. For example, if you see the cost of renewables, cost of the storage through reverse bidding that is coming out, it is falling like anything. So first is that the cost is changing. Number two, there are new drivers of electricity consumption. For example, electrolyzers, data center, electric vehicles. So the inclusion of these type, it is changing the demand numbers as well as their profile. So our crucial study is very important to identify the impact of the demand as well as on the profile. Third, obviously, what is the most cost-effective pathway for integrating more renewables and minimizing the emissions? So these are the motivations. And apart from that, we started this study about 6 months back when there was no other study for 2017. Now the NITI Aayog, which has come, NITI Aayog is a think tank of Indian government. They have come up with a 2070 roadmap as well. But this study outdates that. So this is the team who are working on this project. Mr. A.K. Saxena, Mr. K. Ramanathan, Mr. Ajay Shankar, those are all industry veterans. Lots of experience. They have been guiding us in this project. Mr. Alekhya Datta, he is leading the modeling team. And for the demand assessment, Dr. Ridu Mathur, she is leading the team. And we are very, first also we'd like to acknowledge the support of BEE, Bureau of Energy Efficiency India, as well as the Ministry of Power. Apart from that, support from Bloomberg Philanthropies, who were kind enough to fund us for this study, is also acknowledged. Now, in order to find out the optimal capacity in a mix, the first ingredient, the first input is a demand. So we have used the Markle model for assessment of the electricity demand. Markle is market allocation model. So we essentially divided the consumers of the electricity into 5 sectors: residential, commercial, transport, agriculture, industry. And apart from that, there are many macroeconomic indicators, socioeconomic indicators that goes inside the model. For example, in the residential sector, we have TERI is our in-house model. We require the data of what is the cooking, lighting load, cooling, heating. We have many of the information we have obtained through surveys and our prior studies. In the commercial sector, for example, office, what is the office area, how is it going to project, the hotel area, education, buildings. In the transport, BPKM, BTKM, these all forms the various inputs to the model. Apart from that, the sectoral, the past demand, the pattern, the constraints and the availability, it all goes into inside the model, and model gives you the effective, what is the energy consumption, what is the energy consumption, what are the emissions, and what are the technology options. This is the effective output of the Markle model. So this whole process gave us the annual electricity demand as well as the peak demand. So this is the energy consumption pattern at the national level. By 2070, we see that the total demand of India is going to be somewhere around 17,527 terawatt hour. And the peak demand is going to be about 2,640 gigawatts of hour. We see a demand increase of about 10 times in the total electricity consumption from today's date. And obviously, the major driver for this electricity consumption is going to be industrialization, commercial activities, residential. India is a growing country, so these all sectors will be blooming like anything. Transport, we see an estimated demand of 48 times from the current value. The share of the agriculture, we understand that it will reduce because of the modernization. All right. So once we have the demand numbers, the another thing required is the supply side assumptions. These are the supply side assumptions that we have taken into consideration. Many of them have come from the our previous work. Some of them have come from the reports of the ministries. I would like to specifically highlight the RE resource potential of the solar, which TERI has done ourselves. This is the report that we have recently launched. It says that India has a potential of about 10,000 gigawatts of solar alone. Now, this is where the PLEXOS software comes into the picture. We have the inputs like the demand assessment, solar potential assessment, techno-economical parameters, renewable generation profile. This all goes into the PLEXOS model, and what is the output is the capacity mix, installed capacity, retirement plan, projected system cost, as well as the CO2 emissions. So this chart shows the progress in the installed capacity. This is the decadal roadmap. You may see that most of it the installed capacity is dominated by the solar. A lot of energy storage, BESS will also be required. In terms of energy, again, solar dominates the scenario. A lot of BESS is required for giving the firm capacity, as well as wind is also required. Nuclear is also required for the beating the intermittency of the renewables or for the solar. This shows the installed capacity in terms of 5-year interval. You may see that about 5,000 gigawatt of solar is required in 2070. 3,151 gigawatt of BESS is required. Wind is about 929 gigawatts. In terms of total energy mix, the solar will give India about 8,088 terawatt hour of energy. Support is required from BESS in terms of 1,295 terawatt hour. And obviously, BESS and all types of storage will be required in order to have round-the-clock renewable power. This is the overall share of the installed capacity mix. So we see that about 53% of the total installed capacity in an optimal fashion will come from solar, 33% from BESS, wind will be, I think, 10% in terms of the installed capacity. In terms of generation, 64% is coming out to be generation only from solar, BESS 9%, wind 9%, and coal is, I think, it is definitely going to phase down to only 7%, which currently, it is, I think it is about 69%. So this is the profile of the CO2 emissions from the system. You see that it is continuously decreasing. It is currently at 2,953 MMT. It decreases to 840 MMT. It is a reduction of about 40%, but still emissions are there from the power sector in the long run, into 2070 scenario as well. I mean, this is our interim results. More results, more detailed results may also be required. Yeah, so initially we see that there is a decline in the emissions, but again we see a slight increase in the emissions because of the further coal buildup beyond 2050. So this is the overall system cost which is required for this under this particular scenario. We see that the total cost required for the decarbonization is about $13.53 trillion US dollars. Apart from that, about 0.48 trillion is also required. This is the number required only for one particular year. This is the maximum amount required for decarbonization in one particular year. We see a very stagnant increase in the cost required up to 2050. Beyond that, a bit of volatility. You may see that the graph is fluctuating. So a bit of volatility is there beyond 2050. Now coming to the recommendations and surveys, we see that the 2070 scenario is largely dominated by solar. About 5,000 gigawatt installed capacity of solar to meet this, and it generates about 8,800 terawatt hour in generation. So a lot of push into the solar is required. Apart from that, solar comes during the day only, so a lot of energy storage is also required. So the scalar for the decarbonization is going to be battery energy storage. About 3,000 gigawatt of the capacity of battery energy storage will be required. Since since solar will be there, a lot of demand build up during the evening hours will be there, which means a lot of flexibility is required for the system to operate. Apart from that, we also see that we have seen that some emission increase is also there beyond 2050. So a lot of thought process is also required beyond 2050 to stabilize the emissions. Apart from that, about 5 times cost increase. We see about more than 13 trillion USD is required for the decarbonization. So financial frameworks, strong financial framework, and the optimization is also necessary. Now coming to the global, this is the India level study we have already completed, or we are close to completion. Apart from that, now we envisage building more models. This was under the Viksit Bharat scenario, which is the vision of the national government in India. So we intend to create more scenarios, we intend to create more analysis, and we further deep down into the state level strategies. And apart from that, using PLEXOS for studies in the transport sector and iron and steel. Yes, so those are our priority. Those are going to be our priority areas. Thank you so much. If you have a question, please feel free to ask. If you have an opportunity to collaborate, we are more than happy to do it. In case you want to see some of our reports, you can please scan this QR code. Thank you so much. If you have a question, please
If you have any question, please. Yeah, thank you.
Hello. Yeah, so if you are going to install so much solar PV, it's going to require so much land. And how much do you plan to put it on the roof? And how much to put it on the land? And how, in the model, how it's reflected?
Sure. I think very good questions. I think that is when we do the 2050 modeling studies, the mid-century one. So if we also, in our model, a lot of constraint, particularly on the land availability that we have seen. So what we have done, because in India, if you see, the largest pie of the solar sector at present is utility scale. So what we have done is we assess solar potential of the country, and currently we are also doing for wind. So we found out around what Dr. Ajit has talked about, around 10,000 plus gigawatt of potential, but that does not necessarily talks about utility scale solar. So where, if you talk about around 10,000 plus gigawatt, utility scale solar, we are getting around 4,000 odd gigawatt. But one of the largest potential that we have seen that comes from the agri-photovoltaics, because India is having large, barren lands, also the cultivated lands. So we only consider about the horticulture and those stuff, and the kind of a potential that for agri-photovoltaic that is coming around, again, around 4,000 odd gigawatt. So that means 8,000 gigawatt of kind of a potential that we have in the land, which can be used for the dual purpose. On the other hand, we also assess the potential for solar rooftop. So solar rooftop is also taking one of the substantial capacity on the distributed solar part. And we are also recently we launched a scheme called Pradhan Mantri Surya Ghar Yojana, where we are solarizing 10 million households to start with, and then we'll scaling up. Other than these three options, we also explored the building integrated photovoltaics. So BIPV also having one of the larger potential in the country, because in India we only completed 30% of the urbanizations. If you see the scenarios like 2070, so urbanization will also grow at a speed. So that means a lot of commercial spaces are coming. So BIPV, the building integrated photovoltaics, is also another application that we have considered. And then, of course, you have the metro corridors, the railway corridors. So the road and rail integrated photovoltaics we have also considered. So it's cumulative around 10,000 plus gigawatt. And we also feel the lower cost trajectory of the solar panels, including the panels like BIPV, which is lesser efficient but higher cost. But the scale that we have in the country, I think will be meeting the target to achieve the 8,000 plus gigawatt by 2070 in a competitive manner.
Okay, thank you very much. I'm studying rooftop PV and EV integration, and I'm sure EV also going to increase substantially in India. And I would like to strongly suggest maybe you should consider to integrate EV with rooftop PV or building integrated PV system, so that you can directly supply electricity to EV, and maybe from EV you can supply to the building. So that kind of system may substantially reduce the amount of the land, natural systems.
Yeah, I think absolutely agreed with you. I think when we consider the distributed rooftops, so it comes under the net load, which is basically the negative demand at the consumer level. Of course, EVs, till today, before the war that is happening, the geopolitical issues that are happening, the gas issues or the fossil supply, I think there are many studies has been done at different institutions. The EV penetration, if you see by 2050, 2070, is not that as much as what we have foreseen, because in India we have multiple technologies that coexist. So of course, considering the current geopolitical scenarios, of course EV would be one. But again, another areas, particularly in the residential level, that we are also seeing is electric cooking, because of the LPG issues, a lot of examples are creating now, because shifting to induction and those means, of course, not for the residential sector, but at least for the commercial, the restaurant and all, the lot of shift has happened because of the shortage of the LPG. So of course, these are also already considered in our electricity demand, what Dr. Ajit has talked about in his slides. Thank you so much.
Hi, I'm Aaron from Meralco Power Gen, Philippines. How are we considering or factoring in integration costs of renewables here in our simulations? I understand it's going north of 70% solar in the mix now. So how are we considering costs related to, for example, who handles system inertia or these equipment? Are these factored in as costs or as constraints? Can you share your experience? Or
Ajit, if you'd like.
So we have not, we have considered the cost that we have considered, they mostly are like, installation costs per megawatt. we have not considered that who is going to install it. So that way we have not considered.
No, I think he's talking about more of the system cost. Is cost to integrate more VRE at that level.
That's right.
I think that is when we are developing the net zero scenarios. So I think because in 2050, one of the low fossil fuel scenarios, so we came out with what will be the system cost. So if we go for integrating large, maybe 1,800 odd gigawatt of solar. So similarly, I think this will also do when we're developing the net zero scenarios for the country. Yeah.
Thank you.
The cost which you have considered is only the generation cost, because in India we know the barren land is in different states, but the load growth is in some other areas. So have you considered the transmission corridors cost also?
It's a corporate model at this moment, but will be also building the transmission model into that. So you are rightly said, because we have 9 to 10 RED states, but the evacuation that is, of course, taking place, and the consumption is taking place in other states as well. I think the transmission constraint will also take into account.
So this is cost of generation, not cost of supply.
Yeah.
This is just generation.
Yes.
Cost of
That's
generation.
what I was asking. And one more thing, the load scenarios which you consider, the 4 or 5 buckets.
Sectors,
Yes.
subsectors.
I didn't see data centers in
Data center comes under the commercial.
Yes.
commercial.
Yeah. We'll also, because when we're developing the net zero, then we'll talk about, of course, the specific demand for data centers, the electrolyzers. I think that is inbuilt in the commercial model. So we have not segregated yet, but of course, we'll have a different scenario which talk about the electric cooking, the data centers, the electrolyzers. Of course, a lot of new loads that we are envisaging by 2070, because it's a longer horizon, because there would be a lot of mechanization that will also happen, particularly in the agricultural sector also, like introduction of electric tractors.
Yeah.
So for an example, so I think those also will be, it will run a different scenario for that.
Yeah, because that's a big load
Yeah.
coming up in
Yes.
near future.
Yes.